10 minutes late again. Right. So finish up this last bit on troubleshooting with your electric meter and looking at your different components and everything with that. Typically the electric meter is going to be your number one tool that you're going to see, every day, every call, you're going to have an electric meter out. That's just the nature of it. It's the only way you can verify voltages, amperages, making sure that, power has stuff going through. Because, I don't know how to test that without a meter. You got to have some sort of testing tool. Take care of your meter, keep an eye on it. Don't ever lose it. The last thing you want to have to, I would much rather have to replace a drill or a screwdriver or any tool just about before I have to replace my meter, because it's not the expense of it, it's the frequent use. If I lose my drill, I might be able to get by for a couple of days. I might not have any jobs where I need to use that for. But the meter, I lose that, I misplace that, or it breaks midday, I'm out of work for the rest of the day, unless I've got a backup. So always have extra batteries in your car or your truck, or sometimes I usually kept them in my meter tool bag. I would have an extra set just in case it dies in the middle of working. Didn't never really do that too often. I had it die on me maybe a handful of times, but usually those batteries last a long time. What we've got for y'all's meter is it's a multimeter, is what the term, the common nomenclature, the common word for it is going to be multimeter. Or people will just call it your meter. They won't even, they won't say what it's for. They just grab the meter. So the nice thing about a multimeter is it's got it where it does everything. You can check resistance, amperage, resistance, which is ohms, amperage, voltage. You can check capacitance with certain ones. You can check temperature with different tools on it and attachments and stuff like that. So it really, there's a lot with this meter. There's a lot that can go into it. If you go onto UEI's site, if you go on their website, and I'll show you guys in a little while, you can actually look up components that go with that meter that are, stuff for that. You can find supporting documents and, guides and all that kind of stuff. So, most important thing to check, again, like I've said before, like you guys have seen in the simulations, how it starts. We go to that thermostat, and then if nothing's coming on, or even if stuff is coming on, we're typically going to be starting to look at, let's just check and see, are we getting our source voltage? Are we getting our high? Are we getting our low? Is our transformer working? That's the bare minimum thing you're going to start with. It's just, am I getting power to my system? The second thing you're going to start looking for is making sure that your loads are getting that power all the way to them. Power coming into the system, cool. It's power getting to my motors, cool. And then from there, I'm going to start looking at other components and parts. I'm going to look at capacitors. I'm going to look at the motor itself. If it's not getting power to that, then I'm going to start looking where along the way is there something to stop this motor from coming on? Is there something that is, ahead of everything else that says, no, we cannot turn the system on if this switch is open or something like that. So that's what you're going to see a lot of times for your different systems and everything like that. Is just checking for voltage, checking for power, looking to make sure that it's passing through everything. You check your switches with voltage when they're energized. You can check your motors. You can check your, basically everything. Your contactors. Everything's going to have some amount of voltage going through it. and that's where you're going to start. And it's really just tracing it back. If I go to the outdoor unit and I don't see 24, I don't see 240 and my outdoor contactor at the bottom of it, my first place I'm going to look is I'm going to look right there next to me at that condenser. I'm going to look at that disconnect box. I'm going to open up that disconnect box. I'm going to check, okay, is voltage coming out of this disconnect box? Nope. Okay, is voltage coming into this disconnect box? Nope. All right, let me go back even further. And then you start looking at the breaker. Okay, is the breaker actually tripped or is it working? Oh, breaker sending power out. Okay, so between my breaker and my disconnect box, I'm losing voltage. And that's when you start looking into different things. So that's really all it is with the meter, is really just checking for voltage to see if your loads are getting the proper amount and if your switches are opening and closing correctly. That's what we're going to do with that. Troubleshooting guides and charts are good. They're not the key to everything. It's not going to make it so that you can suddenly solve every problem just because you've got a troubleshooting guide. If anything, it really just kind of points you in the right direction, or might get you to a point where it says, okay, we'll check for this, this, and this. If this is correct, then replace this part. And if you mischeck something on that troubleshooting guide, that's where you can really mess up. If you incorrectly read the voltage on a switch or a motor or something like that, it asks, is the motor getting the proper voltage? Yes. And you're not on the right leads or something like that, or you're checking voltage on the wrong motor, that can easily make it so that it's useless. So for these guides, you really have to know the systems well, and what it's asking for when it's saying to check different components and to look at different things. But really is just going to kind of give you, it's going to narrow things down. That's the main thing that the troubleshooting guide does. Is it narrows things down if you're having trouble doing that yourself. So they can be helpful. I've used them before. They've worked sometimes. More than anything, it's it'll get you to a point where you're just like, yep, that's my problem. That's what I've got going on. This part is not coming on, and then it'll tell you that part's not coming on. Look at here. Blower motor just won't energize no matter what I try. Check a capacitor, check the windings, check this connection. It'll tell you exactly what you need to do. And so that's the nice thing about these troubleshooting trees, is they've got that advantage to them. But if they're not used all the time, they're not used in every system, they're not available for some systems. So don't rely on them. Rely on your understanding of a schematic, of a wiring diagram, of your components and how they work and operate. That's what we're talking about when we say, when you're doing that diagnostic work and everything like that. So yes, the troubleshooting guide is good and helpful. Is it the way that you're going to be able to, get everything working and check all your components? No, it's not always. Now hopscotching, this is something that is very, very helpful. It's simple enough in its idea, but it's tricky sometimes. You got to know what you're looking for when you're hopscotching. Typically, now I've done hopscotching before and I've had this kind of issue, is I'll look at a wiring diagram and I'll see a series of switches in parallel or in series with each other, right? And what I'll do is I'll look at that first switch and I'll check my voltage on it and I'll see, right? It's open or closed. Is it letting power pass through to the next switch, the next switch, the next switch? Now, if they're near enough to each other, I can just keep one lead on that first terminal and then go to the end of that switch, 0 volts. End of the next switch, or start of the next switch, 0 volts. End of the next switch, 0 volts. And I'm just checking every step, every connection after that initial path of electricity, every connection afterwards. Am I reading 0 volts across those switches? If I suddenly read 24, that switch is open. That's what I know. Or I've got a disconnected path or something like that. Or I've got, if it's reading some weird voltage, like 12 or something like that, I've probably got a damaged wire or component. So that's really what you're going to be seeing a lot of times. Hopscotching is really, really helpful, especially for thermostats. Easiest way to do it with a thermostat is to have one leg on your common one probe on your common, and then you're just going to check across all your different terminals, your R, your W, your G, your Y, and C. Where is it sending power out in the system? Y'all will see that when we look at a furnace and we troubleshoot its control board and everything, its thermostat connections. So the control systems, it's logical. That's the whole thing that it's going to function off of is logic. It's going to be open or closed. It's not in between. It's not going to, but it can get stuck open, or it can get stuck closed when it's not supposed to be. And that's when you can have some issues, like trying to find, what the hell went wrong with the system. If you don't realize that, oh, okay, that actually has been stuck in that position. Basically, the main thing you got to understand more than anything is that you've got your electrical components. They're going to be, needing to be diagnosed, and it's understanding how to use your meter, how to read it and everything like that, but then also how to check your different components. What should you see on a contactor? What should you see on a switch or a relay or a thermostat connection or something like that? So when you're looking at the potential of, what is supposed to be there versus what isn't, that's what it really comes down to. Understanding your components, understanding how to use your meter, understanding what you're looking for. That's how you can do diagnostic work better and faster. There's the basic we cover, is all we're really covering. And then when you get out there in the field, you're going to see more advanced. You're going to see new stuff, and you're going to see something you've never seen before, just because that's the nature of the field. And it's up to you to, figure out, okay, wait, hold on. This looks similar to a component I've seen previously. Maybe I should check and see, on my wiring diagram. Let me look at my components. Let me look at, all that kind of stuff. Really, if you ever get in a tight spot and you're not sure where power is supposed to go or something like that, or you're not sure what's connected with what, start looking at that wiring diagram. It's going to be your best tool for troubleshooting and diagnostic work on your electrical and everything. So again, for your control systems, like I said, check your voltage coming in, check your voltage going out. On your control boards, just make sure, like there, locate loads on the wiring diagram. Try and find where they're at, how much voltage are they supposed to be taking. That kind of stuff is really going to make it so you've got a better understanding of what to look for on your components. So the only thing that it's saying here at the bottom that I want to emphasize is never overlook internal overload devices. In a motor, you're going to have internal overloads that will sense temperature or amperage and will shut a motor off prior to it damaging itself. It's the same thing that would turn like a Xbox off. And back in the day, the 360 had that red ring that shut itself down because it wanted to, not damage a component. With the HVAC system, it's going to have the same kind of thing. It's going to have something in that motor that's looking to see how hot is this motor, how high of amperage is this motor. If it gets above what it's set for, it will open and it will disconnect and it will make that motor stop working until that motor either cools off or draws lower amperage or something like that. Always keep in mind that can happen. You can have a motor that looks like it has an open winding, but if you didn't give it time to cool off, then that's not actually an open winding. That's a misdiagnosis. So give your motors time to cool off whenever you're diagnosing everything. All right, cool. So I'm going to bring up UEI's website. So here's UEI's site and everything like that. They've got their products listed where you can find all their different test tools and everything like that. They got new stuff nowadays that connects to your smartphone, which is really nice. Pretty much every brand is putting that stuff out. You've got leak detectors, combustion analyzers, insulation resistance testers, electric testers, all sorts of different stuff. So you've got tons of different controls, but the multimeter, that's what we're usually looking at. So let's look at our meters. And y'all have, which one is it? I think it's this guy. I think. Two different models that look very, very similar. No, yours is the 479, I'm pretty sure. Yeah, because it's got the temperature option. So with this, you've got it where you can find the function, features, standards, includes, downloads, videos, all sorts of cool stuff. And then in here, you can find your logos and products that they've gotten rid of or anything like that. You can call for service, or if your part's under warranty or anything like that, you can always contact them. But UEI, I mean, they make a great, great test tool. So they've got, let's see. They got infrared thermostats and all that kind of cool stuff. So it just depends. Here's just a plain old temperature tester. Yeah, and there's the meter kits. This is what I love. Depending on what kind of meter you got and everything like that, you can buy additional parts for it and stuff. So this is really nice as far as a full kit and everything like that is concerned. This includes, you've got your meter, you've got a temperature probe, you've got a combustion gas leak detector, you've got a manometer that's going to check gas pressure on a gas valve for a furnace, and then you've got this temperature clamp that we use for air conditioning and refrigeration. That right there, this whole kit right here, very nice to have, and it's got a lot of cool little attachments to it. The main thing is your meter, check and make sure, see what its attachments are, see what the capabilities are, and usually most common one that y'all have is you'll be able to get this temperature clamp, which is the one thing I highly recommend you get after you get out in the field for a little bit, because you start doing superheat and subcooling and checking temperatures on everything, it becomes it can become pretty tedious as far as the type of temperature probe that's included with the meter versus the clamping ones that just right on the line. So y'all learn about how those work and everything like that when you get into your air conditioning class and everything. That's when you really go over that. So because that has to do with superheat and subcooling and everything. And this simulation has got it where you can actually hook up gauges and temperature probes and everything. So I can show you guys that a little bit. So we'll go to our cooling, go to our split residential systems. So yeah, I'll do a refrigerant mic. So this is an issue with the refrigerant problem, just to show you guys what you're going to see. So you can turn the system on, you go to the indoor unit, it'll be on, the fan's going to be moving. Go to the outdoor unit, the fan's on, air is moving. And then it's got this set of tools. It's got your nice digital manifold. All right, you can see right here, there's those same kind of clamps like you can have with your meter. And what you're going to be able to do is you can actually hook up your temperature and pressure readings, and you can see what we're looking at for our refrigerant and everything like that. So right here, the nice thing about the digital is it calculates everything for you, but what you're gonna figure out with that temperature probe is you need to know pressure from your meter or from your gauges, and you need to know temperature of that line as well. You need to know those two things when we're diagnosing the system's refrigerant. So, boop, boop, boop. So I keep adding refrigerant, it keeps leaving. So now I'm going to say, okay, well, if my pressure can't stay up, it just goes, so I add some refrigerant, and then all of a sudden this temperature and pressure is going to change back to what it just was, 50/3. So this is when you start saying, okay, screw the meter. And again, if you ever have it where you've got a refrigerant leak or something like that, there we go. Fix the leak. Yeah, that's a joke. Fixing that leak is not the end of our problem. We still have it where our refrigerant's low, so we fix the leak in order to add some refrigerant into the system. That's it. But having it where you're looking at temperature and pressure, those are your two things. Digital manifolds are nice, but having it where you've got access to everything is best. The reason why I laughed at repairing the leak here is this copper and aluminum so close and everything like that, it's really tough to repair a leak on an evaporator coil, almost impossible, especially the amount of time it would take and everything like that. So your better option is always to replace that coil, because if you've got one leak in a coil, you're lucky, but you've got other ones that are on the way. That coil is getting worn out, it's getting torn down, and it's breaking down. And that's just the first issue, is that first leak that you've got in the system. It's gonna have more. So you can repair one, and a week later another one pops up and the system stops working down. That is why typically most technicians will say, I'm not going to repair the leak in a coil, I'm just going to replace the coil. Firstly, it's way easier because repairing a coil is extremely difficult. You've got copper and aluminum right next to each other, and you've got to braze. And it's really hard to braze without damaging some of that aluminum, without hurting the copper, without cooking it or something like that. So it can become rather difficult and very tedious. Having it where we got the coil completely replaced, we only have to deal with our connections, basically right here and right here on the outside of this, or if I was at the outdoor unit replacing the condenser coil that's out here, then I would just have my connections literally right here and right here going into my system. And honestly, it wouldn't even be that. It'd be my connection to my compressor in the middle of it, and then my connection to my discharge line. So typically for a system, we're going to see most of these will have it where if they've got a refrigerant problem or refrigerant leak, you're just going to replace the coil. It's just time, money, and repair-wise, it's just the easier thing to do. It's going to save you time because it's going to take less time. You're going to have a more complete repair because you replace the entire leaky component. And you're going to have it where it's just much easier. Now the problem is with these now that's 2020. It's an R22 system. You cannot be repairing them. You can't be working on them. You can't be doing anything with them basically. There's no coils available anymore. They're just not making them because R22 is no longer a refrigerant we can use. So that's when it really sucks for a customer. I feel like right now we're at that point finally where you go to a customer's house and they've got an R22 system and there's a refrigerant leak. Either you are repairing that entire coil, which costs a pretty penny. If you're repairing in every single leak on a coil, that's some time, that's some money, And that's a lot of hard work to repair just one coil. But if it's cheaper than replacing the system, and they don't want to replace the system, that's their only option. It's either you take the time and repair every single leak you can on that coil, or they get a new system. That's what it gets down to these days. That's the only option. So do a faulty transformer, because that's what we were talking about earlier. So start our thermostat as always. Set the system to cool. Go to our indoor unit. And our fan is not coming on. So I'll check right away. It's not on either. Go back to my indoor. I'm going to check and start with that transformer. If you have a system where nothing is coming on, always start with your source voltage in the system. And then, you know, like I'm going to check for my 240 right now. So I've got my 240, but I looked at my other side of my transformer, I'm getting nothing. So, you know, if I checked that low side and I saw 0 and I said, oh, bad transformer, that'd be too quick of a diagnosis. I have to check voltage out, I have to check voltage coming in. Because if the breaker was tripped or something like that, that would be a different issue. It'd be a different problem I'd be looking at. I wouldn't have to just, you know, oh, get a new transformer in the system. Always, always, always clean it back yourself. Never want to have it in a home where they know you've been there. You know, have it. Whoever wasn't at the house that day comes home or whatever, and all of a sudden, like, oh, is that guy here? Yeah. The HVAC person was here, and they got the work knocked out. So, we didn't even know they were there. You know, so for gas furnaces, we've got a lot of different issues. Most of these are, you know, loose wire or something like that, but we do have some ones that are going to be wire. All right. So integrated furnace control or the control board, we're going to see how would you know that the control board has gone bad. Just like any other system, furnace is going to be the same way we start any other diagnostic. We're going to go to our controls. We're going to start the system up manually by turning our heat on. And then we're going to head to our furnace. The weird thing with the furnace is you got this door switch always that you got to take down in order for the system to turn on. So if you look at our wiring diagram, there's our junction box where where our power is coming in from our breaker panel. We've got the inducer draft motor, we've got a fan motor, and then right here in the middle, we've got this door switch, right? And the door switch is right in series with the power coming from our breaker panel. So as soon as that door switch opens, that's what's going to disconnect power to our whole system. That's why they're used all the time, and they're very, very simple. It's just one switch, open, close, that's it. And it'll stay closed as long as that panel is on there tight, as long as that door cover's on there. So I can look at this and see, okay, what is connected where, what components do I have that I need to check voltage on and everything like that. So something basic I'd look at would be, first, am I getting 120 in? So I look and I see, okay, well, there's my neutral, WH1, there's my hot, BK. And I look at my terminals, I see line 4 and line N, this top one, that is my incoming voltage. That's what I need to check first, always on a control board or any component, is I'm checking that incoming source voltage, my line voltage, to make sure that I'm actually getting power there. So I'm checking line 4, and I'm checking neutral 1. All right, I'm getting 0 volts at the board. So now I'm going to check, all right, well, let me just see real quick. Do I have a loose connection? Well, no. All right. So, oh, crap. Let's go back to it again. Sorry. I clicked on the wrong button. So, thermostat, system's in heat mode. Again, if you have it where you're operating a thermostat, you have to at least change the temperature of that thermostat by 2 degrees above or below whatever that room temperature is. So if I'm looking for an air conditioner to kick on, I'm going to force it on. I'm going to have to set the room temperature to at least 2 degrees below than what it already is. So if it's like, a room set to 70, I'll have to set it to at least 68 for the system to kick on. For a furnace, it's going to be the same way. If it's set to 70, I'm going to have to crank it up to 72 in order for the furnace to kick on. This one gives you an example with the thermostat at the front of this, where it was like 60 degrees and you cranked it up 30 degrees to 90, that's definitely going to turn the system on. If you turn it to the max heat, the max cooling, it will force that system to come on. So, again, like I said, check your voltage coming in. All right, I'm seeing nothing. When I see nothing, now I'm going to start looking, okay, well, let me check my circuit breaker out real quick. Oh. Let's see, does it let me check my meter with it? I doubt it. So my circuit breaker is not tripped or anything like that. It should be sending voltage. Now, in a real world scenario, what I'd be looking for here is I would be tracing pretty much the high voltage wires coming into that system as much as I possibly could. I'd be testing and looking at every wire that's exposed, that's not run behind a wall or something like that, and looking for resistance across those wires. Seeing, are they picking up extra resistance? The big thing I'd look for is continuity, though, as well. Because if I've got it where I've got a meter like this, I set it to continuity. Really? Well, that's dumb. That's not. Well, it won't let me check continuity because it's just a resistance test with a beep. But temperature probe would not go away. But again, if I check my voltage and I'm seeing it, yeah, my breaker's good, but not receiving anything, then I know I've got something where it's disconnected in my wire. Now, for this one, now that I've got it where I'm reading the 120, I know, okay, yes, I've got it where I'm bringing in voltage to this board. Why is it not doing anything? So I'll check my transformer, see if it's putting out the 120 to that transformer. Yep. The transformer giving me back my 24. Yep, transformer sending 24 back. So now I'm going to look and see, okay, well, what about my R to C? Okay, that should be 24 volts. Now the other one should be W to C should be 24 volts as well. So we're getting 24 volts. It's sending low voltage signals out. It's sending high voltage signals out. But yet nothing is coming on still in the system. So now I'm going, well, let me just check and see. Is my meter, or my motor getting power? So this is the first one that's going to get power. Is that inducer draft motor is the first one that's going to kick on. So this is where I start looking at the board. Because at this point, I've checked and seen all of my wiring connections. I've checked my incoming voltage to it. I've checked my low voltage, my high voltage, and yet the system's not sending power to my motors, to my components to turn them on. This is when you say, okay, everything's coming to this board, but nothing's coming out of it, and there's no delay, there's no reason why it shouldn't, you know, that's when you're gonna start replacing the board, you know, and that's basically what it's gonna be. Now, sometimes there will be delays, sometimes it'll, you know, show you as it's activating everything. It'll actually tell you, you know, what's going on with that board. You know, oh, it's in a standby mode, or it's a 90-second delay, or it's a 5-minute delay, or something like that. So you don't have to worry about, oh man, it's not sending any voltage out. Double check and make sure it doesn't have a code or anything like that. Check for a time delay. Typically, that's going to be listed in your wiring diagram with dip switches and controls and all that kind of stuff. So just look for those little things and see, okay, am I really having an issue where they're not having, you know, voltage increase or something like that, or voltage go out to my components? If that's the truth, then yeah, I'm going to start looking at some different stuff. So this is now coming on. One of the last things I'm always going to be doing for most calls is I'm going to do a delta T. So I've got my temperature. My check coming into the furnace is about 70 degrees. And then my temperature coming out of the furnace is going to be, come on, is 110, 109. So I got about a 40-degree increase, which is pretty typical for a gas furnace. If I'm seeing 0, if I'm seeing less, that's when I start looking at your different stuff. You know, it's I'll show you guys with that. That air conditioner, and you'll see the same kind of thing what we just saw with that low AC or low refrigerant kind of thing, or an insufficient charge or something like that. So we got a refrigerant leak. I'm not going to detect the refrigerant leak with my temperature probe, but what I can do is I can see the problem of how much cooling it's actually getting done versus what it's designed to do. It should be about 20 degrees of cooling. Why is it not letting me use my temperature probe now? That's weird. That's very odd. I don't know why it's not letting me check temperature, but if I have a refrigerant leak and my system's operating, like it is right now, I won't notice anything except for a decrease in the amount of heat removed. So typically across an evaporator coil, you should see a 20-degree delta T between air coming in and the air coming out of the top. The air coming out of the top should be 20 degrees cooler. If it's not, then you probably have a restriction either in airflow or in your refrigerant, or a lack of airflow or a lack of refrigerant, something along those lines. Or you could have too much airflow. That could happen as well, where it's you know, it's not cooling off enough because the air is going by so quickly, and it, you know, that just has to do with fan speed and stuff like that. So troubleshooting diagnostics, controls, and all that kind of stuff, it's really going to come down to it's really going to come down to just testing, getting used to testing, what to look for in your different components, you know, your voltages, your amperages, all that kind of stuff. And also always, you know, when you're in these, when you're doing the sim gauge and everything, when you get to that point, make yourself comfortable with the wiring diagrams. These are great ones to practice on. They're very simple, and they'll actually help you out a lot. You can use your meter, I believe. And you can just see, okay, well, where am I going to have my terminal connection? So, okay, I've got the 24 coming in off my transformer, should be across R, and then C, which is this blue. You know, so it's color coded and everything like that. It makes life a lot easier. So you can actually just connect, okay, well, there's a brown wire, there's a yellow wire, you know, all that kind of stuff. I can just test across those, make life easy. But that's it for today. Like I said, I'm going to finish putting up the final. That will be due by Thursday at midnight. Just take it on Canvas, but I'll have it up today, and that way, you know, you'll have 3 days to work on it. I don't have any lecture for this Wednesday or Friday because typically it's just finals is all we'd be doing. So if anything, I might just be doing some more sim gauge simulations. But otherwise, we're done with that electricity book. We knocked it out. Y'all been doing excellent in this class. Thank you. Thank you for all your patience. Like I said, going to get that test loaded up today, and that'll be the end of that. All righty, gents. I will see y'all. Again, I'll just be doing simulations on Wednesday, and probably not going to do anything Friday because I'm doing final grades that day. And I'll have that, you know, everyone will have their exam done already. So just make sure, please take it by Thursday at midnight. Take it before that, not a bad idea. So yeah. Any questions or concerns?
When you say you're putting it up again?
Sometime this afternoon. I should have it. I'm trying to get it. It just takes so much time to copy paste back and forth one question at a time. So because I got to put in like every multiple choice answer and then mark which one's correct and all that kind of fun stuff. So it just yeah.
I'm sending you all my homework stuff right now. So
yeah. Send me all your homework stuff if you got anything else, and you know, that's that should be it. I think everyone's doing pretty well in this class. I think pretty much all y'all have been emailing me and texting me pictures of homework and everything, so I don't think anyone owes anything at this point. I think pretty much everyone's caught up. I'm being pretty lenient this mod just because it's our first online thing. Next mod, I'm going to try and be a little more structured and hopefully have a little more planned out. That's part of my goals this week since I'm not going to be doing as much.
Ain't no bit to get no more structure unless we get up in there.
Yeah, I mean, that's what I really want to see. I'd like to get us just back into school, but we'll see. I mean, the governor put out a different date. Instead of going to be April 30th, it's like June 1st or something. And I'm like, okay, we'll see.
So are you going to be a teacher for our next mod too?
I don't know. I can't recall what my class is for next mod. But y'all will, I'll be sending out emails probably on Friday to all my students for next mod with assignments and everything like that listed out. That's kind of my goal. But again, I gotta do a lot of grading and stuff too. So we'll see. We'll see if I'm able to do that Friday. I'm hoping I can. But, yeah. All right, I'll go ahead. I'm gonna just get working away on that exam, and I'll send out an email when I've got it finished and finalized. And should be able to take it. You might get it. You should get a notification from Canvas that'll say, you know, new quiz available. But if not, I'm gonna send that email anyways, just to remind you, tell you that the quiz is available. Right.
How many questions is it going to be?
50 questions. That's it.
Oh, okay.
Yeah, it's like 45 multiple choice and 5 true false. So shouldn't take long.
Oh yeah, I ain't doing this quiz till like we don't know what we got wrong with the other quizzes, so I'm gonna try to wait to see if you want to grade those and send them back out.
Yeah.
But you know if you is, so you don't think you'll get to it.
Say again.
You know if you will get to the other quizzes and grade them, so we'll know what we missed, or
I won't be able to put up and upload like what questions you missed or anything like that, but okay. I'll be able to at least put your grade up and everything. So.
Well, I'll just do it anyway. Yeah. All right.
All right, again. See you later.
All right.
All right, y'all be safe.